Hey guys, this is Gradius, and this is a video for solving quadratic equations by using square roots. So what we're going to do is we're going to solve quadratic equations. Before, what we've done is we've solved them by graphing. Now what we're going to do is we're going to solve quadratic equations by finding the square root of each side and find the solution that way. So here I have a quadratic equation right here, 2x squared equals 8. So what I want to do is I want to solve this, but without having to graph it. So in order to do that, I'm going to do all my steps as I would do to solve a normal equation first until I get to the final step. So the first thing I would normally do when I have an equation, this is 2 times x squared equals 8. Well, because this is 2 times x squared, I can undo my multiplication by division, the same thing as we've done in the past. These 2's cancel. I have x squared equals 8 divided by 2, which is 4. So now I need to ask myself, x squared means some number times itself is equal to 4. So when I have an exponent of 2, when something is being squared, the way we can undo an exponent to the power of 2 is by taking the square root. And whatever we do to one side of an equation, we have to do to the other side. The square root of x squared is just x. And then I have the square root of 4, which is either positive 2, or it could also be negative 2. So my solution to this equation is x equals 2 and x equals negative 2. And if you just wrote it just simply like x equals plus or minus 2, this would work as well. So either one of these formats would work as an answer. The reason why it's positive or negative is negative 2 times negative 2 is positive 4. Positive 2 times positive 2 is positive 4. So every positive, if I take the square root of a positive number, I'm always going to have 2 solutions. All right. Next, so let's go ahead and do some more examples here. So now I have a quadratic equation. So before, what we did when we wanted to graph it, we would subtract 5 from both sides. And that would give us x squared plus 12 minus 5 equals 0. And then we would graph this function on the left-hand side. Well, we're not doing that anymore, okay, because I'm not graphing. So what I'm going to do is instead of moving the 5 over to the left, I'm going to move the 12 over to the right. So I can get x by itself. So I'm going to subtract 12 from both sides. I have x squared equals 5 minus 12 is negative 7. Now what I would do is I know that some number times itself equals negative 7, so I need to cancel out this exponent power of 2 by finding the square root. Leaves me with x equals the square root of negative 7. I got to ask myself, what times itself equals negative 7? And the answer is nothing. There is no solution. And the reason why is because this is a negative number. You can't have the square root of a negative number. It doesn't work. Okay, because if I have to multiply the same number by itself. Well, if I were to take any number and multiply by itself, is it possible for me to get a negative number? So I'd have a positive times a positive, which is always positive. And then I would have a negative times a negative, which is also always positive. So because no number multiplied by itself can equal a negative number, that means I have no solution. In other words, this parabola never crosses the x-axis. Okay. Next here, what I have is I have 4x squared equals 9. So we're going to follow the steps of solving an equation by dividing by 4. So I have x squared equals 9 over 4. I'm just going to leave it as a fraction instead of finding the decimal for this. Now, follow the same steps. I have a power of 2, so I'm going to take the square root just to get x by itself. So the x equals the square root of 9 over 4. Well, the way we find square roots of fractions, this is a review from previous lessons, is I can divide this into x equals the square root of 9 over the square root of 4. And therefore, x equals plus or minus 3 over 2. And again, it's plus or minus because the square root of 9 over 4 can either be positive or it could be negative. So therefore, those are my 2 solutions, positive 3/2 or negative 3/2. Another one, let me see, I got one more after this. So 3x squared minus 11 equals 7, so I want to get the x by itself. So the first thing I'm going to do is add 11 to both sides. It's going to give me 3x squared equals 18. Now I can divide by 3 to try to, I'm still working to get this x by itself. x squared equals 6. And then now I can cancel out this exponent by finding the square root. So I have x equals the square root of 6. Well, the square root of 6 does not have it's not a perfect square. I don't have a whole number where if I multiply it by itself, it is going to give me 6. So what I can do from here is I can approximate. I can guess, make a strong estimate as to what the square root of 6 is. So I know, to make my estimate, I know the two perfect squares as the square root of 6 is in between is the square root of 4 and the square root of 9. Because the square root of 4 is 2, the square root of 9 is 3. So then I have the square root of 6. Well, the square root of 6 is in between these two numbers, so that means my solution is going to have to be plus or minus 2 point something, because it's in between 2 and 3. So it's going to be 2 and then plus something that puts it in between 2 and 3. Well, if we look, square root of 6 is closer to the square root of 4 than it is to the square root of 9, but it's almost right in the middle. There's only 2 and 3 in between. So it's almost right around 2.5, but a little bit closer to the 4. To this number. So I'm going to say it's a little bit closer to 2 than to 3, so I'm going to go with an approximation of about 2.4. And that would be my answer. That would be a good enough approximation. If I had a calculator, I would just be able to plug it in and go from there. Okay, so one more problem. And we have 6 times x minus 4 squared equals 42. So now I have these parentheses here, and I have the exponent on the outside. So what I'm going to do first is I'm going to get rid of the 6. That's the first thing I want to do. So I'm going to get rid of the 6. This is 6 times all of this. So what I can do is just divide by 6 on both sides. These cancel out, because again, this is just multiplication. So I'm canceling these out. So I still have x minus 4 over here, squared, is all equal to 7. So that means all of this number here squared is equal to 7. So what I can do is I can still, because this is raised to the power of 2, the square root will cancel out this power of 2. And then I can take the square root on this side. I now have x minus 4, I don't know what happened, x minus 4 is equal to the square root of 7. From here, what I can do is I know the square root of 7 is going to be a plus or minus. It's going to be a positive or a negative number. We're not sure what it is. Okay, and I'm just going to leave it at this like this for right now. Because now what I can do to get x by itself, I can just add 4 to both sides. So I really have x equals plus or minus the square root of 7 plus 4. So my two solutions, if I didn't want to approximate, if I wanted to be exact, I didn't want you to estimate, I would accept x equals the square root of 7 plus 4, because this would be for the positive square root of 7, and x would also equal negative square root of 7 plus 4. Both of these would be acceptable answers, and I would finish from here. If I had a calculator, I would just plug in the square root of 7 into my calculator and then add these together, and that would give me my exact solutions. And if I wanted to estimate, I could. It'd be probably around 2.6 somewhere, and I would be able to go from there. So, and I'm all done. Okay, so the big key for this problem right here, though, you guys, is that if you have parentheses with the exponent afterwards, it doesn't matter. You can still take the square root of both sides, and that'll cancel out that exponent. Okay, this is it for solving equations by finding the square roots. I hope this helps, and good luck. Thanks.